Looks like we are live. We'll start in a few minutes. Just wait for people get on the live stream, and I'll fix a few things. We'll start in a few minutes. Just wait for people get on the live stream, and I'll fix a few things. I need to do this real quick. Right. So we have a question. First question, lab 3, number 3. So this is integration by parts. And for this, we do not need to use a table. So we just use the formula. Right. So I will do the integral first, indefinite integral, and after that I will deal with the limits later. So we ignore the limit for a moment. So u will be x, and then the v will be e to the negative x. Right, and then we have derivative. So du is dx. And to get back to v, we'll integrate, which is e to negative x over negative 1, or just negative e to the negative x. Right. And then we put into that formula. So that will be equal to uv x negative e to the negative x minus v and du. We will use the table a little bit later, but for now I'll just use that formula for this problem. Right. So we simplify, we'll have negative x e to the negative x, negative and minus a negative, so that is positive e to negative x dx. Right. And so we have negative x e to the negative x. This we already did. It is negative e to negative x, but let's do that again. Right. We could do the plus c, because here we do not have the limits. So to simplify, we have negative x e to negative x, negative e to negative x. Right. Now we get back to the problem with the limits. So now we have that integral. We do not need to see here when we have the limits. That goes from 0 to 6. Right. So we're just going to put 6 into it. Put 6 in for x and have that. And then minus, where we put 0 into x. Right. So 0 times anything is 0, so that 1, 0, e to the 0 power, this is 1. And looks like we have negative 6 e to the negative 6 and another 1, so this combined like terms will have negative 7 and minus a negative 1, so plus 1. Let me check it. is correct. Yeah. So it's like that. Right. Since we're on this one, I just want to go back to number 1 on the same lab 3, just to do this integral with the table, because we have kind of similar thing with exponential function and polynomial. So on this one, we'll kind of the same thing. We'll have u and dv, but instead of just write u and v, I will write in general something we want to differentiate and something we want to integrate. Right. So same thing. On this one, we let u equal to x. So the order of choosing u is log. Algebraic would be the x, the power of x. So this is log, and this is pronoun space. And then the exponential will be less. So on this problem, we do not have any log. So we go with the algebraic expression, which is the polynomial of power of x. So that is x squared here. And e to the 2x. Will be on the other side. Right. This side I will differentiate 2x, 2, and 0. The other side I will integrate. Integrate, I should write this earlier. Integral of e to the kx is e to the kx over k plus c. Right. So this will have e to the 2x over 2. So 1/2 e to the 2x. And then I integrate again, will be 1/2 e to the 2x over 2 e to the 1/4 e to the 2x, and then we have 1/4 e to the 2x over 2 will be 1/8 e to the 2x. So we have 1, 1/2, 1/4, 1/8. We could go further, but since we're going to do the diagonal, whatever here we'll multiply by 0 anyway, so that's as far we need. Right, after that we have the diagonals. The first one is positive, negative, and then positive. Right, so that original integral will be equal to x squared times 1/2 e to the 2x minus 2x 1/4 e to the 2x plus 2 1/8 e to the 2x, and the next one will be 0, so we're not going to have anything after that, so it's done. So just plus c. Right, just simplify this a little bit. That is 1/2 x squared e to the 2x. This 2 and 1/4 is 1/2. And then that 1/4 e to the 2x plus c. You can stop here, or you can also factor. Looks like all of them have e to the 2x. We can factor it out. And then we can also do the common denominator and factor it out, but that is far we go. Right. So that is 1. Yeah, lab 2 we don't have any iteration by parts. Since we on the iteration by parts, just want to take a look at lab 2, number 4, at least to set it up. I checked email about 15 minutes before the stream, and I did not see any questions. So right now I just pick up some random problem with progression on most of the questions on the same topic. Then I move on to the next one. Right. If you have any questions, please put in the chat. Right. Right. So pretty much we have the derivative, and now we find the net growth. So derivative, to get back to the function, we just need to integrate from 1 to 3. Right. Usually this kind of question, along with the one in the morning flow, if you can set up the formula or the integral, the calculation, you can use the calculator. So let me get the calculator. Right. So calculator, under math, yeah. So after this one, we'll go to number 17 on lab 3. Under math, option number 9, we have the integral that goes from 1 to 3, and the function is 30x e to the 2x. Right, check the answer. Oh, I do have the answer for this, but let me find it. I'm not sure if I hand out the answer for lab 2, but I do have it. If you have any want to check any of them, just let me know. Yeah, that is correct. Right. By the way, I need to switch to the other calculator. So that is this, but let me switch the calculator. Right. This will be the same math option, I believe, still number 9. The syntax in that case, we're going to enter the function, and then the variable, and then lower and upper limit. Right. So in this case, we will write the function 30x e to the 2x. That is the the function. The variable is x. That goes from 1 to 3. And then we have the same thing. When I after I'm done with the stream, I will post I will send out an announcement about this video, and I will attach the key to it. Yeah. Right. Also, for this test and for most of the tests, if the question, this is very important. If the question like this give the answer in exact form, when you see that, you should not use the calculator. If it is not specified that you have to give exact answer, you are free to use calculator. That including something like number 17 on lab 3. Yeah, so I think I'm going to 7, lab 2 7 first, and then I'll go back to lab 3 on 17, because we should have this one. So which one first? Let's do the one. Okay. Let me update the list first. So this we have the volume of the solid of revolution rotating about the x-axis. By the way, it could get complicated, but on the test you always have just rotating about the x-axis, so it will be not much. In that case, the volume will be equal to pi a to b, the values of the function square, and then dx. The a and b will be the limit of the region. So a and b, I should write this is b. Yeah, so we will have this region rotating around about the x-axis only. Right. So 16 and 17 will be similar. So for this, I would quite have to sketch the graph. I look at the graph quickly. Y equal to square root 81 minus x squared. I saw that look like a circle. It is a circle, by the way. The radius equal to 9. We only interested from the part when x go from 0. Oh, sorry, cannot see it with the calculator there. Only interesting the part that goes from 0 to 9 and y equal to 0. So pretty much we're talking about this one. Right, and now the volume. That is the function. So we will have pi from 0 to 9, and the function is square root of 81 minus x squared. Square that dx. Square cancel the square root. Have pi times integral from 0 to 9, and that's just 81 minus x squared dx. Right. And just as mentioned before, any definite integral, any integral with the limit, if I did not specify that you have to give the exact form or have to show work or anything like that, you just put in the calculator. So this part here, I'm just going to put on the calculator. So yeah, since I have this mode, I just go ahead and use it. Math 9 81 minus x squared, or x doesn't matter. X is the variable that goes from 0 to 9. 486. Notice that we only put the part in here, not the pi. If you put the pi in it, the answer would not be anything nice and even. So that integral itself is 486, and the answer we just stick a pi to it. So 486 pi. So most of this kind of problem, I just want you to set up the problem, set up the integral, and once you have the integral, just go ahead and evaluate it. Like I said, unless I ask for to show the work in the integral, or you have to give exact answer, then you have to do it by hand. Otherwise, you can use a calculator. For this kind of problem, if we have a pi, I'll just leave it out Just do that first, and then stick the pi at the end. Right. Next we have lab 2, number 7. And after that we will go to lab 3, either 20 to 22. Alright, let's go over the formula first, because this kind of problem we just need to set up the problem. Alright, so we have the flow of money at that for 10 years. So first, if we just have the money flow, then we just have the integral from 0 to t, the function. And usually it is a function of time, so even though it is x, we'll convert that to t. So if we just want the money flow, will be just that. If we want the present value, it will be like that, but we'll stick the e negative rt. Notice that this is the little t, this is the capital T. So I should say t, uppercase T, capital T is a constant. And will be given in the problem. So in this case 10 years. So in this case capital T is 10. A constant should be given. It is 10 in this case. Right, so we stick that in for the present values e to negative rt. The reason for that is, let me just write a little note here. Future values a equal to p e to the rt. So we denote something here. A is future values or accumulated values, and p is the present value, and r is the rate, t is time. So that's one clear. If we want to solve for the p, the present value, I will divide e to the rt on both sides, and we have a divided by e to the rt equal to p. If we move this up, we have p equal to a e to the negative rt. So when we move it up, it becomes e to negative rt, and that's why we multiply by e to the negative rt to it. Right, the future values. The future values will be just the present values times this, which is the original formula here for the future value. So we will multiply e to the r, but this time it is the capital T. And then the integral. Right, so that pretty much all three formulas related to this application. Right, let's go to this problem. What we want in this problem, present value. So it's going to be this 4%, so that is the rate 10 years. That is the capital T, and the function of the money flow will be that. So we have present values. We'll start with the formula. So in this particular problem, we just have 0 to 10. I should write everything given here. So T is 10. The rate 4%, meaning 0.04. The function, I should convert that to T. And that's it. So 0 to 10, the function, and the rate 0.04 T dt. Right, as mentioned before, anything definite integral that have the limit, anything that has the limit and it did not specify that you have to give exact answer or show work, just going to use the calculator, and I'll do just that. By the way, if we have to do this, it is integration by parts, so suddenly we run out of space, and so we use calculator on this one. The setting up part is a lot more important than the answer itself. Right, so yeah, just keep this calculator. Math 9. The function. Notice there's a parentheses here, so we have to have an extra parentheses. T. X probably the easiest variable, so I'm just going to use X here. Plus 100. And then times E negative 0.04 X close, and that is the function. Variable is X, that goes from 0 to 10. This problem 7. A 25.74. See if that works. Yeah. I just put the whole thing in the calculator. It's just the whole integral in the calculator. And if it is the problem with money, we round that to decimal places. Right. Usually, if you use the calculator on the test, just on the top of the equal sign, just write using calculator. So I know that you use the calculator. Of course, I kind of get the idea as well. Right. I want to go to lab 3, number 22, because that is the future value problem. Right. So this one is the future values. So future values is that. I'm just write the formula first. This is a capital T, a constant. Integral 0 to T the flow, money flow, e to negative r. This is a little t, and then dt. And confusion part, this should be capital T. I mean, that's fine. I mean, we do know it is 10 years here anyway, so t is equal to 10. The rate 8%. And the flow function right. So put this together, we will have e to the r %. Yeah, don't confuse with that 0.04. So 8% is the rate, 0.08 for 10 years. So this is capital T is a constant. The integral that go from 0 to 10. The flow function is this. And sorry, we should convert that to T. Yeah, function in terms of time. So everything should be in T. That is f of t. Right, so 500 e to 0.0 ft. I will change, and that e to the negative rt, that different things. Just going to keep that. Will be e negative r and t. Et. So, yeah. So this, of course, is that. Yeah, both of them have a, so it is kind of confusing. Right, first, combine this, we have e to the 0.8 integral of 0 to 10, 500 e. Right, now multiply two things with the same base. We can add the exponent 0.04 minus 0.08. So we have a negative 0.04 t dt. Right, so pretty much just that. And just calculate wait. Right. E turn on e to the 0.8 times the integral negative t that is the function. The variable x goes from 0 to 10. Right. Check the answer real quick. Yeah. 9,171. 171.45. Right. Yeah. So we have that. Yeah. So pretty much just these formulas. The accumulated amount is the future value. Right. So I think that covered the question on the business or the finance kind of problem. Right. What's next? Let's see. I think we just need to do the average values function, and after that, improper integral. So, average value function, I would look at 19, and then number 5 on lab 2. So, average values of a function. Right. So pretty much what we have is a function from a to b, and the average value function, it will find the average height of the function. Of course, because the function has infinite number of values, so we cannot find the average like we normally do by adding all of number and divide by the total number. We have to do using integral and divide by b minus 8. So I'm looking 19 here. So will be the integral will be from 0 to 2, and then the function and then have 1 over 2 minus 0. Exactly that formula. So I have 1/2 the integral right. Right. So check this out. That looks okay. Right. So calculator again. Like I said, setting up POC is a lot more important for this kind of problem. So you may have 1/2 first, and then the integral. Or if that's a bit complicated, we'll just do the integral first and then multiply by 1/2 later. So just the integral. X cubed minus 3x squared. I just use x or x squared, doesn't really matter. Plus 3x minus 1, where x goes from 0 to 2. Right. If you use a calculator, you have this number. By the way, that is e to the negative 14, meaning times 10 to the negative 14, which is extremely small number. In fact, that is just a calculator error. So that's in fact should be just equal to 0, because this number is too small. The calculation the calculator make what we call the machine error, so it's extremely small. So we just say that equal to 0. Of course, if it's anything you see, if it is e to the negative and more than 10, that most likely is the machine error. So 1/2 times 0 is equals 0. Yeah. So just the setting up part is a lot more important than actually get the right answer here. Alright. On the average values of the function on lab 2 is number 5. Sorry, let me update the list. Let me update the list first. Right. For the average for the first 10 days, meaning that we go from 0 to 10, and this is a function. So yeah, so that's the formula. Yeah, I should do that. Right, so 1 over, just write the formula again. So we will have 1 over 10 minus 0, 0 to 10, the function. Doesn't matter, we can use x or t, but if we use t, then it should be dt. If you do that on a calculator, you should have 35. Right. I can switch. Right, so pretty much 1 over 10. So if you have this calculator, you can get a fraction. It does the same thing, really. Sorry. $35. Right. Right. Just realized that I should do number 6 on this lab too as well, even though it is the volume, but it's kind of interesting. Right. So the volume of a cone, the height is equal to 10. Put the calculator away. Right. We should look at the cone like this, but it would be much better if we rotate around and we say the cone is kind of like this. the height of the cone will be just this, which is 10. So we go from 0 to 10 here, and the radius, the base radius is 5, so this is 5. So because that is the volume of revolution, we just need to find out what is this function. Right, so we have the linear function. When x equal to 0, y equal to 0. And when x equal to 5, when x equal to 10, y equal to 5. So pretty much if you look at the slope, rise over run, rise 5 over 10, so it's pretty much y equal to 1/2. This one doesn't have the y-intercept, so it's just y equal to 1/2 of x. And then the volume of solid of revolution. We go from 0 to 10 from the limit. The function 1/2 x square dx. Right, so we do that, we have pi. I could use a calculator, but this is simple enough. 1/2 square is 1 over 4 x square dx. Right, the integral will be just 1/4 x cubed over 3. That goes from 0 to 5, 0 to 10. So that will be pi times 1 over 12 x cubed 0 to 10. Alright, so pi, and we have 1 over 12. I'm going to put 1000, 10 in it, we'll make 1000. And minus pi 1/2. Of course, put 0 in it, we have nothing. So that 1000. So we have pi 1000 divided by 12. And we can divide 4 from it. So we have 250 over 3 pi. I can just do that. So 1000 divided by 12 pi, so divide by 4 top and bottom, have pi 250 over 3, or 250 over 3 pi. Yeah. And also just to note, volume of this a right circular cone is of a cone in general 1/3 base area times the height. So 1/3 pi r square, the base area, which is a circle here, times the height. We use the number we have in this problem. 1/3 pi, the radius is 5 square, and then h, the height 10, and we should get the same thing. Right. Next we do the improper integral. So anything from 20 on left 3, 23 to 26 because remember in class we did say that we omit number 27. We don't have any improper integral on lab 2, so pretty much just this 4 problems. By the way, all of the improper integral, the one with infinity, pretty much you have to do it by hand, simply because we cannot put the infinity on the calculator. We could put a very big number like negative 99999 something for infinity, but you need to use a need to show all the work here for those. Right. I do 23 and then 26. Right. 23. So improper integral, there's no really formula for it, except we're going to just make a change of infinity to a constant. So we have the limit. We'll change this. If it is a lower limit, we say it's going to be a. So we take a goes to negative infinity, and we go from a to negative 5. By the way, 2 over x to the 5th, I can write 2x to the negative 5 dx. Right. And then we just integrate like we normally do, and we worry the limit on the last step. So integral will be 2x to the, we plus 1 to it, negative 4 over negative 4. That will go from a to negative 5. Right. Next, we just evaluate the integral. Right, 2 over negative 4, that is 2 over negative 4 is negative 1/2. And x to the negative 4, we can move that to the bottom. So pretty much that, which goes from a to negative 5. We put negative 5 in it, we will have negative 1/2, negative 5 for x to the 4th power, and minus negative 1, 2, a to the negative, a to the 4th power, sorry. Now, I do this first, 5 to the 4th power, 625 times 2, just need to calculate. So, negative 1 divided by 2 times negative 5 to the 4th power, negative or positive to the 4th power, it's the same. So just do that. and then minus the negative, that's a plus. Now when a goes to negative infinity, this will go to 1 over 2 negative infinity to the 4th power. The bottom will be infinity. So what we have here is a constant. If we have a constant, to put that back, constant divided by something that goes to plus or minus infinity will be equal to 0. So that one go to 0, and that's what we have. Right. So that is 23. So constant divided by infinity is 0. 26. I'll do 25 in 2 seconds. First, since x goes to infinity, this function we have 17 times infinity, a to infinity. By the way, a to infinity is go to infinity, and x go to infinity. So pretty much the whole thing here will go to infinity. Now if we talk about the area, doesn't matter where we start. If we just go indefinitely to infinity, the area from 0 to infinity, of course, is going to be infinity as well. So this one just simply divergent. Because that goes to infinity. I mean the function goes to infinity, the area because of that will be unbound. So divergent. Don't have to do much. Pretty much if this function does not go to 0 and we have indefinite limit like this, it should be divergent. Right. 26. After this we'll go to chapter 9 about the partial derivatives and second derivative test. Definitely we have to look at lab 2, either 9 or 10. Right. 26. By the way, I just want to do this quickly, just have to see if it works or not. For this one, let's assume that we will do the integral on the calculator. Alright, so this one we don't know the negative infinity, so use I think that's enough. On the top is negative 5. On the function alpha y equal 2. It will not give us a fraction. By the way, let's look at that again. Yeah, so that's why we cannot use a calculator on this one. So it doesn't work at all. 26. Right. So first I will change the limit. That's always the first step. Infinity upper limit, that will be b. Right. If you move the a to the x up, there's still a limit. One to be x e to the negative x dx. Of course, that one is integration by parts, which is pretty much like we normally do. So integration by parts. Yeah, I skip a few steps, and that's what you should get anyway. Right. So integral, we will have positive, negative. After that, it's just 0. So x and e negative e to the negative x. Minus one to b. By the way, when we have this, if any of this goes to infinity, we just say that will be divergent. So keep that in mind. Right, first I put b in it. This definitely I need to do. And then e to the negative b minus e to the negative b. Right? Yeah, there's a lot of things going for this one. Next, minus 1 for x, e to the minus 1 minus 1 minus e to the minus 1. Right. We can leave it like this, but it would be better if we have the negative exponent and we try to make it positive. So here we will have negative b over e to the b minus 1 over e to the b minus negative e to the negative 1 minus e to negative 1. So that will make it 2. Just hope that we do on the right track. Right. Of course, we can change that to 1 over a as well, but I'll focus on this one really. Next, b goes to infinity, so I have 1 over e to infinity, which is also 1 over infinity, which is 0. So that one go to 0. That's easy. Now this will be a problem, because if we put infinity in it, we have infinity on the top, infinity at the bottom. So this one is, just write down for the moment, infinity over infinity, which is indeterminate. Which bring back to calculus 1, where we do something like this. So now interested to find the limit when b goes to infinity of negative b over e to the b. Right. Clearly we have infinity over infinity. The only way to do that, one of the way to do that is the L'Hopital rule. So we take the limit on the top. Derivative of negative b is negative 1. Derivative at the bottom, e to the b, still e to the b. Right now, if we put infinity to it, a constant over infinity is 0. So that one goes to 0. Actually goes to 0. So that's 0. We just live with this. So negative, inside we have, you can write 1 over e. Sorry, too many negative signs. So negative 1 over e minus 1 over e. That negative 2 over e with another negative 2 over e. So this one we need to use the L'Hopital rule on that to find the limit for that. Now we go to the partial derivatives and second derivative test. So what was the last one? Oh. Right, partial derivatives. I probably would do 29, 31, definitely. So look at look at the first one. That's simple enough. So derivative with respect to x. So we treat y as a constant. So first, ax derivative with respect to x will be 8. That's normal. Next, this one with respect to x we have 14x. Then y squared is a constant. So if with respect to x, y is a constant, we just have that constant because all together in one term. If you have the whole thing as a constant by itself, derivative will be 0. So we just have 8 plus 14x y squared. Right. The next one, we can take derivative like that, but it requires the chain rule. The power square here we can actually multiply it out, but if it is different powers like 5 or 2.5, we cannot really multiply it out, so we use the chain rule. So I put this in the box. I have, let's take derivative with respect to x first. So I have the box square, and the box is 5x to the 4th y cubed plus 6. Put u here. Derivative of this is u squared I'm sorry, 2u. Derivative of u squared is 2u. Derivative of this with respect to x will be 20x cubed and y cubed. 6 is the constant, derivative is 0, so we have that. So that is derivative with respect to x. So that will be 40x cubed y cubed and then u, which will be 40x cubed y cubed and then u. We can multiply it out or not, but I'll just leave it like that. So that is with respect to x. Now with respect to y, it will be similarly to this. So the box square and the box is 5x to the 4th y cubed plus 6. Right. Derivative 2u. Derivative here. This time with respect to y it will be different. 5x to the 4th, it is the constant. Y cubed will be 3y squared. So we have 2 times 5, 10 times 3, 30. U x to the 4th y squared. So 30 x to the 4th y squared u, and u is just that. So potentially we might have a chain rule in the partial derivatives. Thirty. Right. Like that would be difficult. I will not do it, but I'll just give you a little hint. This is x power. We'll bring it down. Now do it like that. And derivative should be extremely easily to do. So x is a constant, derivative of this with respect to y, then with respect to x. Should be simple. 31. I think we did something like this similar in class. So I do it anyway. So derivative with respect to x. I write that to denote. We take derivative with respect to x. We only have x here. Derivative is 1. Y e to the negative y is a constant, so we just stay there. So we have y e to the negative y, and just that. Now, derivative with respect to y will be a lot more interesting. Now we take derivative with respect to y. Right. In that case, x is a constant, and that is the problem. We will take derivative of y e to the negative y. By the way, to write the derivative, we can just write like that, meaning we take derivative of that thing inside the parentheses, right? So proper notation, f sub y, x is constant. Now derivative with respect to y, I'm going to use the product rule. derivative of y with respect to y is 1 e to the negative y. For v, let's use u v. U will be y. Derivative of that is negative e to the negative y. So simplify this, we have e to negative y minus y e to negative y. Right. Now the second order partial derivative will be similar to this. Right. So first we have fyx. The good thing about the mixed partial derivative is fyx is the same as fxy. So either way it's good. So what I do is I will take derivative with respect to y first. So from here, take derivative with respect to y. So 3x cubed is a constant. Derivative with respect to y is 1. This is minus 14y. That's it, and 2x is a constant. So that is derivative with respect to y. Now if we want yx, we will take derivative with respect to x. That becomes yx. I should write more detail like this in class. Derivative of, let's simplify that first. Ax cubed minus 14y. That is a constant. Derivative with respect to, this time with respect to x. Derivative of this with respect to x will be 24x squared, and that is a constant with respect to x, so will be 0. So just pretty much 24x squared. 33. I think this is y that will be better, but just have to deal with it. In fact, that just I'll put it this in the an announcement that we'll skip this one. Just write a lot. What was the other one? 27. Yeah, I put on the canvas announcement later. Right. Next we do the second derivative test. And find the maximum and minimum. By the way, on the test, I will not ask you to do one complete problem like this. Just either critical points or maximum minimum. Right. So first, we do both in this one, of course. First, I'll find the critical points for this. We take derivative with respect to x. X cubed will be 3x squared. Negative 12x will be negative 4 y. That's it. There's no more x. Derivative of this function with respect to y, negative. 12x is constant. Derivative of y is 1. Plus, that will be 24y cubed. Right. But it's going to be a long time, so right. So critical points is where the partial derivative equal to 0, and with respect to x, with respect to y, both equal to 0. So that's where we find the critical points potentially. Right. So 3x squared minus 4y equal to 0, and negative 12x plus 24 y squared equal to 0. Right. So either we use substitution or elimination, but in this case, if we want to eliminate x, that we multiply by x, or eliminate y, we multiply by y. That looks complicated, so I will try to solve for either x or y and then use substitution. I will solve for y here. So I move the 4y to the other side. I should have 3x squared equal to 4y. So y will be equal to 3x squared over 4. Keep that in mind. 3x squared over 4, that is y. I will substitute into the other equation. Right, so that would be negative 12x. Need a calculator for this one. Plus 24. Right. We square the top, square the bottom. So it will be 9 x to the 4th over 4 squared 16 equal to 0. And to simplify 24 and 16, that will be 3 halves divided by 8. We have the 9 there as well, so just do all the constant together. 24 times 9 and then divide by 16. 27 over 2. Right. Unaligned fraction, so let's just multiply everything by 2 and get rid of fraction. Right. Next, try to solve for x. So I'll do factoring. Look like both of them have x, and both of them divisible by 3. So I will factor out negative 3x. Inside that will be ax minus 9. Sorry, just 8. There will be no x here. So negative 3x is 0, so negative 3x is 0. I have to continue over here. So if x equal to 0 and a minus 9x cubed equal to 0, meaning if you solve for x cubed, it will be negative 8 over negative 9. Shoot. Yeah, I just checked the answer is not that, so I don't know how to write 4y here. Right. Better change all of that. Right. That should be 12y. Sorry. We'll try that again. Yeah, I'll try to fix that, but that will be a mess. Right. Derivative with respect to x. 3x squared minus 12y. Derivative with respect to y. Negative 12x. Y is a constant. Derivative with respect to y. X is a constant. Plus 24 y squared. Right. Critical point again. F of x equal to 0. F of y equal to 0. Yeah, that might look better. We'll see. The same way I will solve for y here. So y equal to 3 divided by 12 is 1/4, so x squared over 4. Right, I'll substitute into this y. So I have negative 12x plus 24 x squared will be x to the 4th over 4 squared, which is 16. Equal to 0. Right, simplify that, we have negative 12x 24 over 16, that is the 3 halves, x to the 4th equal to 0. Multiply everything by 2. Much better this time. factor out negative 3x. So we have that. So negative 3x is 0, a minus x cubed is 0, this gives us x equal to 0, and that gives us x cubed is 8, which means x is 2, where we take the cube root on both sides. Right. So when x equal to, now we substitute back for this one. When x equal to 0, y 0 squared over 4 is 0 as well. And at x equal to 2, that is 1. So we have 2 points, 0, 0, and 2 and 1. So that's the first step. The second step is second derivative test. Sorry. That was off screen. Right. So second derivative. Let me just rewrite the derivative. So we take derivative with respect to x. With respect to x, from here we have fxx will be 6x, and that's it. The derivative of this with respect to y, we have fxy will be negative 12. Of course, we can also do fyx. Fyx is equal to fxy, so that's why those two, this one with respect to x and this one with respect to y, should be equal, same thing. And we take the derivative of this with respect to y, fyy 40ay. Now the derivative test at 0, 0. At 0, 0, I'm going to put 0 here, here, and here. So fxx is equal to 0. 6 times 0. fxy is negative 12. fyy is 48 times 0 is 0. Then I do the discriminant. I don't know how I write the squared. Just d. Fxx fyy minus fxy squared. So 0 square, 0 times 0 minus negative 12 square. Right. So 0 minus negative 12 square is 144. And with the negative 144, this is less than 0. So it is a saddle point. And then we test the point 2 and 1. Fxx If you put 2 in for x, we have 12. Xy still negative 12. Fyy put 1 in for y is 48. And then the discriminant again. Well, take a lot of space for just one problem. I don't know if I keep doing that. It should be D2 subscript actually. Right, so 12 times 48 minus negative 12 squared. I don't have to do this to see that 12 times 48 is bigger than 12 times 12. So this is going to be positive. So if it is positive, we can say it's either max or min. So max or min if it is positive. Negative is a shadow point. 0 is inconclusive. To determine if it is max or min, we just look at either one of this. And this one is positive, which means open up, which means it is a local mean. Local mean at 2 and 1. Right. So what's that? Let me zoom out that. Take a lot of space. Right. That better. Right. I'll do one more problem. But first, I will omit number 36. That will be too much. Right. Next, I'm looking at either number 9 or number 10 in the problem, and I see that for sure number 9. We're not going to do this number 9. I'm going to omit this problem, but we have the box, and it has 3 variables, and the volume is xyz equal to 16, so z is equal to 16 over xy. Right. Because of this similar region of number 36, I'm not going to we need to omit this problem because partial derivative will be very complicated. So omit that as well. Just I'll post on the canvas later. But I'm going to do number 10 instead. Right, at least this one very straightforward. So find the number to maximize profit. So a lot more manageable from this one. So pretty much we have the revenue and the cost, the profit function that has two variables now. Revenue minus the cost. Just like last problem, I just divide the page in half because that takes a lot of space. I just find the function first of all. Right, revenue 2.5 x plus 4y minus the cost. Okay, this one a lot more manageable, a lot more reasonable, I should say. Oh, simplify it first. 2.5x plus 4y minus x squared plus 2xy minus 2y squared. Right. Now, we find the critical point or points. This one is a lot more manageable. I'll take derivative with respect to x. That will be 2.5. That constant minus 2x plus 2 and then y. Derivative with respect to y 4 plus 2x minus 4y. Right. And then we will have the system of equation. But first, critical point, the partial derivative equal to 0. We can just zoom back in, it doesn't take that much space. This one we can even use the calculator. Right. Right. I will put this in the standard form. The reason that we can use calculator because we just have x and y and the number. On the last one where we have the square, it will not work. If we have either y square, x square, or any higher power, or we have x, y in it, it doesn't work. If we just have an x, and y, and a number, that will work. So negative 2x, 2y equal to negative 2.5. I just move that to the other side. And then 2x minus 4y equal to negative 4. So that's system of equation. We use calculator on this one. Right. What we use is the reduced row echelon form and matrices. Let me try to put this as big as possible. Yeah, that better. Right. So I'll hit second matrix. And first I have to enter this in. This is a matrix of 2 rows, 3 columns. So edit 2 rows, 3 columns. Negative 2, 2, negative 2.5, 2, -4, and -4. Right. When I'm done, I can quick. Now go to second matrix again. This time go to the math and go to option RREF. I'm not sure where it is, but on different calculator, but it will be this option. And then we hit the second matrix again. Go to math. I'm sorry. Just keep on the names. And we'll do that. We have 4.5 and 3.25. We can almost stop at this step because the problem asks for a point to maximize profit. We only have one point, so it must be where the profit is at maximized. But we use the second derivative test to confirm that it's actually a maximum. So second derivative test. By the way, it is 4.5 and 3.25, but in thousand. So actually it should be 4,500 hundredths and 3,250. As mentioned before, when I send out an announcement, I will attach the answer to these problems on lab 2 as well. Right. So first derivative with respect to x is that. Derivative with this is just p, not r. Sorry. With respect to y. Now take derivative with respect to x. We have -2. With respect to y of that will give us fx, p of xy. With respect to y will be just 2. Derivative with respect to, I'm sorry, I should not put xy here. We just have x. We have x already, now we just with respect to y. So if we take with respect to y already, now if we take with respect to x, we have p of y x, which is the same as p of xy. As you see, derivative of this with respect to x will be just 2, which is the same. So the mixed partial derivatives are equal. So pxy is the same as pyx. And that is the reason why in the discriminant we have f of xy squared. Technically, it should be f of xy times f of yx, but because they are the same, so let's make it square. Y will be -4. Right. Yeah, doesn't matter. I mean, those points, there's no x and y in it. So we still say at x 4.5 and 3.25. We'll put everything in it. Discriminant fx x fyy minus the mixed partial derivatives square -2 -4 minus 2 square. We expect to have positive answer here because when it's positive we have either max or min. If this one is negative, this is a shadow point. A shadow point. And it is indeed positive. So we have either max or min. And we look at pxx or pyy, actually either one of them is fine. And that is negative. meaning open down, meaning we have a local max. So we say local max or maximum profit at x equal to 4.5, but since it is in thousand, we say 4.5 thousand or 4,500. Right, yeah, this is much better. In fact, I think I'm going to put one on the test where you find the Greek points and using the calculator. So I'll make sure you know how to use the RREF option. I mean, should say function. Anyway, I think I'm going to stop the video here. That cover a lot of different things, and I think that should prepare you for the second test. I'm going to post that at the same time when I send out an announcement along with the attachment of the solution for lab 2. Right. As always, I hope this will help you to prepare for the test. Thanks for watching.